Hi, sir.
Hello, Amy. How are you doing?
I'm good, thank you. How are you?
Very good, very good. So, how is the review on circles going on?
Yeah, really good. I completed so many questions for my book, and only had three that I didn't know out of
Oh,
like 70 or something.
oh
So
my God. So, 3 out of
it's
70
good.
missing. 67 you
Yeah.
got. That's excellent. Amazing. So, great job done. So, you feel confident, right?
Yeah.
Share with me
I
those three
do.
questions. We'll work on that. So, what I thought is that I'll just take in a small portion of this circles chapter, um,
Mm-hmm.
and I've taken 3 or 4 questions from that section, just as a mock quiz, you can say. Let me ask
Yeah.
you those questions and see where you are, right? So those are related questions. One of them could be in your test also. So I'll share with you those questions and let's see how you are working on that. And later you share with me the 3 questions which you have. We'll discuss
Okay.
those later, okay? Now,
Yeah.
so here are the 4 questions for you, Amy. Can you please read them and answer? First, it'd be good if you could suggest the strategy to solve them and then answer these questions. Okay?
Right.
Starting with question number 1.
Question one. Point C, 3C, lies on the circle with diameter A, 1, 2, and B, 9, 6. Find the area of the triangle ABC.
Yes. How
Okay.
will you do this question?
So I think the first place to start would be finding the point C, so the other value, which is C. So to do this, as it lies on the circle, we have the diameter. So from the diameter, we can find the midpoint, which would be the center of the circle.
Okay.
Then you can use the center of the circle and then find the equation of the circle just by using the center of points. And then find the radius using the center with, let's say, point A, because it's a simpler point, and then write down your whole circle equation, then sub x is 3 into that equation, and then you
Mhm.
can get C. And
Okay.
then since we're trying to find ABC, so since AB is the diameter and C is just one of the points,
Yeah.
there'll be like a right angle triangle in the semicircle. So you just do Pythagoras' theorem and then work it out.
Fine. Well done. Well, your method is perfectly fine. I mean, I should say it's correct method. However, I will not like to do it in that fashion because that may take too long. So, can you repeat the steps? First step was you find the center, correct?
Mm-hmm.
Center. That is the midpoint, correct? And then you say you'll find the radius, correct?
Yep.
And then you say you find the equation of circle. Okay. And then what do you do? You find
Sub the
circle
x.
and then you solve for c, right?
Yeah.
Using distance formula, correct? Which involves square root, right? So
Oh,
the
I was just going to solve for C by putting x value into the circle equation.
x value and find y. Okay, okay. So you will not use distance, so that's good. One step you saved. So you'll find f of 3 and you'll get the value of c, right? This is what you
Yeah.
did, right? Anyway,
Mm-hmm.
but what you came out with at the end was absolutely correct final solution, and that you said that we have a right triangle, correct?
Yeah.
So in a semicircle, we have a right triangle, and then you will use Pythagorean theorem, correct? Something like this. What did you say?
Mm-hmm.
How will you find
Yeah.
the uh,
So, there I would have to use the
then you
distance
use the
formula.
distance formula. Then you find the distance formula, right? And then find the length of the sides, correct?
Right.
And then you find the area. Okay. So these are the steps which I've seen so many times students following. They do get the right answer. But see, I'll share with you the method now, and you will appreciate how we could do this question in quarter of the time. I mean, not even half. Okay. So
All right.
before giving you the answer, what I thought is that I'll share with you hints. So now look here into this particular situation. Actually, this is a very, very good question, and I've seen such questions in examinations so many times, right? So we are given the diameter, which is point A and B. As you can see, this line in between is the diameter. We are given a point C, x value of point C. First thing to note here is that there is a possibility of two triangles to be formed. Since, circle for x value may have two y values, right? It is not a function, it is a relation. So keep that in mind, that there is a possibility of two triangles. And in this case, it's real that we have two triangles involved. The question doesn't say which value of C you have to use to find the triangle, area, correct? That means
Mhm.
find area of triangle of basically two triangles at the same time. Perfect. If you miss on one of them, you miss half the marks straight away after spending so much of time. Okay.
All right.
Now, look here. You also observe that since we are given the diameter, the point C lying anywhere will be like forming a semicircle, and therefore the triangle will be a right angle triangle. Now, whenever you are looking into a right angle triangle, you should think about the legs which are perpendicular and their slopes are negative reciprocal. So if I use the slope formula, y2 minus y1 over x2 minus x1, and negative reciprocal, we are only dealing with simple linear equation to solve. And that way you get the point C. And once you get point C, you do the later half, which is you ultimately find the length of AC and length of BC. Because at C, we have the right triangle, right? Right angle is at C.
Mhm.
We don't have to find the diameter length at all to find the area. To find the area, it is half base into height, and base and height are the smaller sides of a right triangle. Remember that. Now, when you solve your equation, you'll also see that you actually get two values of C. So you have to find area of both the triangles. Does it make sense to you?
Yeah.
Okay, so let's go through this solution once and understand what we're talking about. So Amy, here is the solution which I'm sharing with you. The question is, we have a point C, which is 3C, which lies on a circle with diameter given to us. We need to find the area. So we realize that the triangle ABC is a right triangle since it is in a semicircle. So we have assumed that there is some point C which is lying there, and we know that the angle which is being formed at C is a right angle, and that right angle is at C itself. And therefore, we are going to use this particular concept that the slope of M to AC and the slope from C to B, that is negative reciprocal. That means their product will be -1. Well, you know the 2 points, only point missing is the y value of C. So let this be the variable for you. So I'm saying that my equation will be y minus y1 over x minus x1 as the slope. And in both the equations, C is involved. So I've got two equations where C is involved. I can equate them and find the answer. So the first one will be y minus y1 over x minus x1, slope of AC, which is this line. So we have on the top C minus 2, those are the y values, divided by x difference 3 minus 1. Correct. So that is what we get. And well, I didn't complete it here, but anyway, I had to write C minus 2 over 2, right? Okay. So basically, this is C minus 2 over 2. Now we'll find the slope of BC, which is C minus 6. Now I'm using this point, 9 and 6. So y value of 6 and 3 minus 6, that gives me this particular equation. And their products have to be -1. And just multiply them, you should get -1. Then you just, the remainder is 2 times -6, which is -12. Multiply by -12, that becomes 12. And this is your equation to be solved. And when you solve this quadratic equation, factor it out, you get two values of C, 0 and 8. So we did not have to find the midpoint. You see that? We did not have to
Mhm.
find the radius and all those steps we saved on, which is like half the exercise saved, correct? And we also realized that we got two values of C. With that procedure, also you will get actually two values later on, but this is how we're going to get. Now, since we have two values of C, now we have to find area of two triangles. So I'm labeling the other triangle as C dash. And therefore, the area will be find AC and BC. Those are the sides. You could simplify that, but not really required. We're ultimately multiplying them, right? So when you multiply these two square roots, they vanish. and you get 40 divided by 2, and 20 units square becomes the area of bigger triangle, which is on the top half. And in the lower half, we get the second triangle, substituting the values, we get the value of this area as 12 units square. Do you realize this part? Correct? So when you look at this question, you cannot even imagine that this question may involve two triangles and area something like this, correct?
Yeah.
This is a very interesting question and seen so many times in previous test papers, so it's worth taking a good look at. Okay?
Wait, so are there two answers for this then?
Yes,
20 and 12.
Yes.
Oh.
So these are the two answers. So one is this and the other one is this, since we have two triangles right there.
So if you write just one of them, you lose half the marks.
The marks will be lost.
Oh.
Correct. Until and unless they give some other condition, right? So they may say one of the triangle is an isosceles triangle, find the area of that one, or maybe, because you see one of the triangles is an isosceles triangle in this
Yeah.
problem. So these values are used in many different ways to find different kind of an, or they may say, find the area of the triangle which is scalene triangle. Then you may get confused. I mean, it might throw you off. But if no conditions are given to you, then you have to find area of both the triangles.
Well, oh, okay.
Perfect. Now let's move to the second question. Question number 2. Can you please read this?
Yes. Question 2. Circle x minus 5 whole squared plus y minus 2 whole squared equals 125. Intersects the positive coordinate axes at A and B. Find the area of the triangle AOB, where O is the origin.
Yes. So how will you solve this question?
So since the circle equation is given, oh, wait, intersects the positive coordinate axis. Oh, okay. So since it's the coordinate axes, we need to, so if it's the x-axis, so that'll be an x-intercept. So all we do is make y equal to 0. And if it's a y-intercept, you make x equal to 0.
Correct. So what I did was that, to give you a hint, for each question I've made a figure. We will come to know about this figure after we solve it. But to discuss, this is a good thing to look into. So what you're saying is that we do have a circle which is shown in red here, correct? So you want to now find what are the x and y intercepts, and definitely to find x-intercept, you substitute y equals to 0. For y-intercept, you substitute x equals to 0, correct? And then you just need to find the area of the triangle, correct? With the origin O. So the area is the shaded region, blue in it, right? So in this particular case, Amy, to save the time, only find x and y intercepts. You are given the origin and find the area. Don't find center, radius, or anything else. Does it make sense to you?
I was just about to do that. Yeah, that's why it threw me. Yeah.
So that is a simple question. But imagine if the examination, they expect you to do it in, let us say, 3 minutes. You're going to find so many extra things and, waste 3 extra minutes on it, which will not be worth it. Right? That is why this question is very important. Simple, beautiful, and can make a lot of difference in the performance of a student. Okay, so we are looking for such questions. So we need not even discuss its solution, but anyway, I'll show you the solution. How simple it looks. Okay, it doesn't really look that simple here. So we have realized that we do have a right angle triangle since we are talking about the axis and the origin. So whenever you're looking at axis and the origin, the two coordinate axes will always intersect at right angles. So a simple case of right angle triangle where you only need to find the x and y intercepts to find the area of the triangle. So what we do, as Amy was saying, we find the x-intercept by substituting y equals to 0. Well, we get two values. Now it says with positive coordinate axis. Do you see that positive coordinate axis? So your condition is negative. Yeah, not the negative one. So you have to select the positive value 16 in this particular case. And similarly for y also you'll get two answers. And then again, the positive value of 12 will be selected. So this one side is 16, the other one is 12. Just multiply, and half of that is the area of the triangle. Clear? Perfect. Let's look into the question now. So can you please read question number 3 and tell me your strategy?
Yes. So question 3. The tangent to the circle x squared plus y squared plus 8x minus 2y minus 225 equals 0 at point P, which is 7 minus 10, meets the x-axis at A and y-axis at B. Find the area of the triangle AOB where O is the origin.
Yes. So how will you do this question?
Okay. So since we've got the circle equation, we can simply find the center by doing like that minus G and minus F thing. So
right, negative sign, correct?
Yeah. So minus 4 and 1 would be the center. And then since we got a point, since we got the point P, we can find the gradient of the radius,
correct.
And then negative reciprocal would be the tangent.
Very good.
Find that equation, sub the point P in.
Correct.
And then, yeah. Well,
perfect. That is perfect. So I don't really have to explain you anything in this particular case. What you're doing is exactly what should be done, right? So you just nailed it. So you first find the center, which is negative half of these two coefficients, x and y, negative half, right? So we get minus 4 and 1 as your center. We know that the slope of this radius is negative reciprocal of the slope of the tangent, and that is what we take care of. So we have this negative reciprocal slope of the tangent. We know the point P and the slope, and that helps us to find the equation of the lines. And once you have the equation of the line, you can always find x and y intercepts, and then product of those two intercepts with half gives you the area of the triangle. Done, right?
Mm.
Perfect. The last question for you. Question number 4. Can you please read this?
Yes. Question 4. Points P 9 minus 5 and R 3 7 lie on the circle with the center C 2 minus 1. If QP forms a diagonal of this circle, find the area of the triangle PQR.
How will you do this?
Okay, so we would have to find point Q.
Yes.
So since we've got the center,
yes,
and we've got P, we can find Q by using the midpoint formula.
Perfect. Here is your diagram. You're right. So we have P, we have the center, and you can find Q with the midpoint formula, correct. And we have the point R. That is absolutely correct. So once you do that, then you have your solution right there, and similar to the previous questions. So we'll jump on to the solution, right? So we are given diameter is PQ. So let the coordinates for Q be X and Y, right? Which we need to figure out. We are given the center, which is 2 minus 1. We are going to use the midpoint formula, and the midpoint is at C, which is 2 minus 1. So average value of Q and P coordinates, and there you go. Solve individually each one of them to find the value of X and Y. So you get the coordinate of Q as minus 5, 3 in this particular case. Once you have that, you just find the two sides. Again, no need to simplify these radicals 180 and 80 square root. I know it can be simplified, but we are multiplying them, correct? We are multiplying them. Just multiply. Use calculator, get your answer done. Do you see that part?
Yeah.
Is that clear to you? So that is how we are going to answer these 4 questions. And these are very common questions in test paper. Some way or the other, one of them is definitely there in any test paper. You can open GCSE level A on this particular topic. One of them will be there, right? Any year you can pick up. So I hope that helps. How do you find this exercise? Short and informative, I hope.
Yeah, definitely. I'm now liking your style. You know, every time you put questions, you ask me to think of how would I attempt it, because this is as close you would get to as the exam. So if I'm in the exam, I see a question, I would know how to now attempt it and what strategies to use and how to save time the most efficient way. So yeah.
That is true. That is true. And when I ask you a question online like this, it is you're just seeing the test paper, right? You just see the test paper and say, oh my God, the 4 questions there before you.
Yeah.
It's a real experience of solving it. right there and then, right? The only thing here is that I can guide you what mistakes you could have done, what mistakes you could avoid, and how
Yeah.
could you do it better. That's the whole approach. So once we have few mock sessions like this on each and every topic, you're well set to really do your best in any examination, right? So that's the whole idea. So it's good that you liked it.
Yeah.
Thanks for now, and we shall be connecting again. But share with me those three questions which
Sorry.
that you had difficulty with. 3 out of 70, right? Very good.
Yeah.
3 to 7, almost you're above 97% for sure. That means that's great. So
Yeah. Thank you so much, sir. I really
thank-
appreciate it.
my
Thank you.
pleasure. Thank you, and all the best.
Bye.